Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the previous video we started with the concept of MOS amplifier. Okay, so first of all I started with the small signal model. In small signal model, I told you the MOSFET will work in saturation region, and we need two parameters for MOS amplifier. One is the transconductance, which was del ID by del VGS, which is equal to 2 under root K into ID, and we need the output resistance RD, which is 1 by the conductance GD, or 1 upon del ID by del VDS. This came out to be 1 over lambda times ID. And then I told you about the first amplifier, which is common source amplifier. In this common source amplifier, we derived the voltage gain as minus Gm RD parallel capital RD into R1 parallel R2 by RSI plus R1 parallel R2. Okay. Now, one thing that I want to tell you here is, in BJT we compare this source with ammeter, drain with collector, and gate with base. So in BJT we studied that the most common type of amplifier was common emitter amplifier. Similarly, in MOSFET, the most common type of amplifier is the common source amplifier, and the common source amplifier has the highest voltage gain. Like in common emitter amplifier, we told that it has the highest voltage gain. Similarly, in MOSFET, common source amplifier has the highest voltage gain. Is it fine? So in this video, what we'll do is we'll take a look at some other amplifier configuration, and we'll derive certain parameter like input resistance, output resistance, and voltage gain. So first I'll see about common source amplifier. Now if you see, in common source amplifier we have a resistance RS. Earlier this RS was not there. So what I will say is, this is a common source amplifier with unbypassed RS. Like in BJT, when we had common emitter amplifier with unbypassed RE, the gain should reduce because this resistance acts as negative feedback. Now whenever we are performing amplifier analysis, the step 1 is always the same. We have to perform DC analysis. In DC analysis, we open circuit capacitor, and our aim will be to find the drain current ID. Then I will find transconductance, which is 2 under root KID, and the output resistance RD. These parameters I will find using the DC analysis. So I am not performing DC analysis. We have seen DC analysis in previous videos, so I know how to perform DC analysis. So now when I move to step 2, when I talk about AC analysis, then I will short this VDD, or I will ground this VDD. and I will also short the capacitor. So what we will do is, this is the input voltage Vi. The capacitor is shorted. Due to grounding VDD, this R1 and R2 will come in parallel. R1 parallel R2. Now this is connected to gate. Between gate and source we have voltage VGS. Between drain and source we have a current source GMVGS. Now this is the source resistance RS. In parallel with GMVGS we will have a resistance RD, and between drain and ground we have a resistance capital RD. And this is V0. So this will be the circuit. Now we need certain parameters. The first one is the input resistance. Okay. So first I need input resistance. Now if you see from the figure, what is the input resistance here? It is simply R1 parallel R2. Okay. Now when we talk about other parameter, the other parameter that I need is the output resistance R0. Now it is equal to V0 by I0 when the input voltage is 0. Now see, suppose this voltage is V. If you apply KVL like this, so by KVL what you can say? VGS plus V equal to VI. Now if you keep Vi equal to 0, you will say V equal to minus VGS. Okay. V equal to minus VGS. We need V0 by I0. I0 will contain 3 currents. So what I will say? I0 contains 3 currents. One in RD, V0 by RD. The third one, V0 minus V by RD plus GM VGS. Okay. Because the voltage here is V, the voltage here is V0. So what is this current? V0 minus V by RD and GM VGS. V is minus VGS or V is minus VGS, or you can say VGS is minus V. But I need to eliminate V from here. How do I eliminate V? What you can do now is, in order to eliminate V, one thing that can be done, I know this current I0 is sum of 3 currents. I know V is minus VGS, but I need some relation between V and V0. Okay. So what I will do is, the current in this resistance, it will also be I0. Why it will be I0? Because I0 is coming, it will not be I0 actually. This will be GM VGS plus I. Suppose this is I. Okay. So what I will say is V is GM VGS plus I RS. Okay. Now I is this current. I is the current in the small RD resistance. I is the current that I have shown, this one. So now VGS is minus V. I is like this. So what you will do is, you will collect the term of V, 1 plus GM RS plus RS by RD equal to V naught RS by RD. So V is V naught RS by RD 1 plus GM RS plus RS by RD. Now what you can do is you can substitute the value of V in terms of V naught, and then I can calculate I naught. So I naught was V naught by RD plus V naught by small rd. Then what about V? These two terms contain V minus V GM plus 1 by RD. 1 by RD plus 1 by small rd. Now if you substitute the value of V, if we substitute the value of V, then what will happen? It is V naught RS by RD. So GM plus 1 by RD, then RS by RD, 1 plus how much it is? GM RS plus RS plus RD. Now what you can do is, one thing, if you want to do something here, what you can do? You can either say RD is very high, so you want to ignore RD. That you can do. If you ignore RD, or you can say 1 by RD tends to 0, then output resistance is approximately capital RD. Because this term will vanish, this term will also vanish. So what will be left? Only capital RD. Otherwise from here you can compute V naught by I naught, and that will be the exact value of output resistance. Now the most important parameter, that is the voltage gain. Okay, we want to find out the voltage gain. Now to find out the voltage gain, we need to find out the value of V naught. Again let me do one thing, I'll ignore capital RD in order to simplify the analysis. Ignore RD. If you ignore RD, then what will this circuit become? It will be removed from here. Now what I will say is, this GM VGS current is flowing like this, which means polarity across RD is opposite to the given polarity. So what I will say is V naught is minus GM VGS RD. But I need to find the value of VGS in terms of V. Now this V voltage can be given as the current in RS is GM VGS into RS. That is the value of V. And see, the current here is GM VGS into RS will give me V. And as I told, if you apply KVL, what you can say, that VI is VGS plus V, which means VGS 1 plus GM RS. Now V naught I wrote as minus GM VGS RD. So if you calculate voltage gain, V naught by VI, VGS will get cancelled out. So it is minus GM RD over 1 plus GM RS. Now see, in this case, if this RS source resistance was 0, if RS was 0, then what would have happened? If RS was 0, then the gain would have been minus GM RD. That means due to this RS, the gain of the amplifier has reduced, and that is the working of the negative feedback resistance RS. RS acts as negative feedback to reduce the gain of the amplifier. Moving on to the next amplifier, that is common drain or source follower. In BJT, we studied a similar amplifier which was common collector or ammeter follower. We were calling it as ammeter follower because the output terminal was connected to the ammeter terminal. So we were saying it will follow the ammeter voltage. But here the output terminal is connected to the source terminal. So it will follow the source voltage, and hence it is the source follower, or you can call it as common drain. Now again our first step would be, step 1 would be perform DC analysis, in which we will find out the value of ID. So the trans conductance would be 2 under root K ID. Now step 2 will be when we will ground the voltage VDD and we will short circuit the capacitor. In that case we will form the small signal model. So let me start drawing the small signal model. First I will have the input voltage Vi, then I will have the source resistance RSI. The capacitor will be short, but since you are grounding this VDD, R1 and R2 will come in parallel. Okay. R1 parallel R2. If such a thing is happening, now between gate and source, I will show the voltage. Sorry. This terminal is actually ground. Between gate and source, I will show the voltage VGS. Then between source and ground, we have resistance RS, across which the voltage is V0. Then we will show a current source GM VGS. In parallel to this GM VGS, we will have a resistance R0, and this drain terminal is connected to ground. Okay, so that will be the model of the amplifier. Now what I want is the parameters of this amplifier. The first parameter is the input resistance. Always remember, in input resistance we never consider the source resistance. So what is the input resistance of this amplifier? Tell me, seeing the figure, what is the input resistance? The input resistance RSI is R1 parallel R2. Okay, that is the input resistance RSI. Sorry, not RSI, RI. Now we need other parameters such as voltage gain and output resistance. So let us start with voltage gain. Suppose so in voltage gain I want the gain V0 by Vs. Okay, that is the overall voltage gain. Now when you talk about V0, see one thing. This terminal of RS and R0 is connected. The other terminal is also connected. So what I'll do now is, I will remove this R0 because I know both terminals of R0 are connected to the two terminals of RS. So I'll remove R0 from here. Then what I will do is, I'll draw R0 or RD, small rd here. RD and R0 are same. Now, V naught is the voltage across parallel combination of the two resistances. What is the current going here? The current going here is GM VGS. So what I will say is V naught is the voltage across parallel combination, which is GM VGS into RD parallel RS. Now in order to calculate V naught by Vs, we need this Vs in terms of VGS. So suppose I call this voltage as V, or let me redraw this circuit in a certain manner that will be easier to understand. Both these terminals were grounded. So in order to use a single ground, I can connect like this. Okay. Suppose I want the voltage V. You can say both the resistances are in series. So this voltage V is actually source voltage Vs multiplied by the factor of voltage division R1 parallel R2 RSI plus R1 parallel R2. That is the voltage V. Now if you apply KVL, this voltage V is actually sum of two voltages, VGS and V naught. So it is equal to VGS plus V naught, or you can say VGS 1 plus, if you substitute V naught in terms of VGS, you can write like this. That means the source voltage is VGS 1 plus GM RD parallel RS into RSI plus R1 parallel R2 over R1 parallel R2. Now when you take the ratio V naught by Vs to find the overall voltage gain, then this ratio will be GM RD parallel RS by 1 plus GM RD parallel RS into a factor of voltage division R1 parallel R2 RSI plus R1 parallel R2. In BJT I told you two types or three types of voltage gain, AV, AVL and AVS. So the first term that you are seeing here, this term, that is actually the voltage gain AV. Now AVS is equal to AV if the source resistance is 0. If this resistance is 0, R1 parallel R2 will get cancelled out. So that means to find the overall voltage gain, what I have done? I have multiplied the voltage gain with a factor of voltage division. And even if you see this first term AV, the denominator is higher than the numerator, so the voltage gain of source follower is less than 1. That is the same thing that was happening in BJT. In emitter follower, the gain was always less than 1. The third parameter that I will derive is the output resistance. Now this output resistance R out is simply V naught by I naught when V in is 0. So suppose I make Vi equal to 0, then I can say V is also equal to 0. If I say Vi is equal to 0, then I can say V is also equal to 0. Is it fine? Now both these things are equal to 0 and I am asking you the value of V naught by I naught. Now there are two incoming currents, I naught and GM VGS, and there are two outgoing currents in RS and RD. So I'll say I naught plus GM VGS is equal to V naught by RS plus V naught by RD. Now if you see, this voltage V is sum of two voltages VGS and V0. Okay. So if I substitute that V equal to 0 equal to VGS plus V0, so VGS is minus V0. Substitute in the first equation. I0 minus GM V0 is V0 by RS plus V0 by RD. Take GM V0 on the right hand side. GM plus 1 by RS plus 1 by RD into V0. That means V0 by I0, that is the output resistance, is RS parallel RD parallel 1 by GM. That is the overall output resistance of this source follower or common drain amplifier. Okay. Are you getting my point? How to calculate? We always calculate V0 by I0, but by making the input voltage 0. Moving to the last amplifier, that is the common gate amplifier. It is analogous to the common base amplifier that we study in BJT. Again, the step 1 for this amplifier is perform DC analysis. In DC analysis, what we have to do? Open circuit capacitor. So how you will form the circuit for DC analysis? See, this capacitor will be opened. So this current source will remain IQ V minus. Okay. This capacitor will also be open, so the resistance will remain RG. But there is no purpose of this RG because the gate current is always 0. Then CC2 will also be open, V plus, and this is RD. Now we already know the DC current. This is basically constant current biasing. So the drain current is IQ. From here I can calculate the transconductance, which is under root KID, which will become 2 under root K IQ. Then we can calculate the drain resistance, which is lambda ID, or still you can say lambda IQ. Now this is the first step in which we have calculated the small signal parameters. Now what we need to do is we need to design the small signal model or the AC model. So let me draw the AC model. For that, what I'll do is I'll short circuit the capacitors. See how I will draw. VI, ground. We'll go step by step. Don't get afraid by seeing the circuit. This is RSI. Then when we are talking about AC, we will open circuit the DC current source. So this current source will be removed. Between source and gate we always have open circuit, and this voltage is written as VGS. Okay. Remember, when you are writing VGS, the gate terminal should be positive and the source terminal should be negative. Between drain and source, we have a current source GM VGS. This is source, this is gate. Now this is drain. Now you will ground the DC supply. When you ground the DC supply, the drain is connected to ground by means of a resistance capital RD. Then you will short circuit this CC2. When you short circuit this CC2, it is connected to another resistance RL, and this voltage is your V0. Now the gate terminal will be directly connected to ground due to the short circuiting of CG. So this gate terminal is grounded. I am not showing this resistance RD. I am assuming that RD is very high, hence open circuit. Otherwise, if you want to consider RD also, you will have to connect it in parallel with the current source GM VGS. Now, instead of using multiple grounds, let me do one thing. Let me connect all these grounds to a single ground. Like this. I will write this as gate terminal. Now, what I need to do is I need to find the parameters. So let us start finding the parameters. Suppose first of all I am asking you the most important parameter, that is voltage gain. Voltage gain is simply AV V0 by Vi or Vs. This I am showing as Vi. Now how to calculate V0? First of all, this RD and RL are connected in parallel. So let me replace it by a single resistance. I will write here RD parallel RL. Now this current is going like this, plus and minus. That is the polarity is opposite to V0. So what I will say is V0 is minus GM VGS into RD parallel to RL. Now I want to eliminate this VGS in order to find the voltage gain. So what I will do is, how to eliminate VGS? This current is GM VGS. So plus minus like this. So let me apply KVL like this. So I will say minus VGS minus GM VGS into RSI equal to VI. So Vi is minus VGS 1 plus GM RSI. So when you want to find the voltage gain V0 by Vi, VGS will get cancelled, minus will also get cancelled. So GM RD parallel RL into 1 plus GM RSI. So that will be the overall voltage gain of this amplifier. The next parameter that I will find is the input resistance. Now while finding the input resistance, one thing that we do is we ignore the source resistance RSI. Now this input resistance will be the ratio of input voltage, or Vin I will write, and the input current In. So from the figure we can say Vin is minus VGS. See this. The polarity of Vin is opposite to VGS. So Vin is minus VGS. What about this current In? I can say In is minus GM VGS. So what is the input resistance? Vin over In. It is 1 by GM. So that is your input resistance, 1 by GM. The last parameter that we need to derive is the output resistance. How to find output resistance? Tell me. It is V0 by I0, but when Vi is 0. So let us modify the circuit. So first I will delete this Vi. I will say V0 by I0, but remember, when we are calculating output resistance, we ignore RL. RL should not be considered. So I0 is sum of two currents, GM VGS and this current going in RD. Now we have to find this VGS. How to find this VGS? By applying KVL like this. So what I will write? This current is GM VGS, right? The current going in RSI is GM-VGS. So I'll write KVL. How I will write KVL? Minus VGS minus GM-VGS RSI equal to 0. From this equation I can say VGS is equal to 0. If VGS is 0, I naught is basically sum of two currents. One current going in RD plus GM-VGS. I have just now proved that VGS is 0. So it is V naught by RD. So what you will say, V naught by I naught is RD. So RD is equal to your output resistance. Okay. So if I summarize what we have covered in this lecture, I have told you three types of amplifier. Common source amplifier with unbypassed RS. We saw there is a factor of 1 plus GMRS in denominator. So it reduces the gain. Then we saw source follower, but I told you in source follower as well as emitter follower, the voltage gain is always less than 1. And the third one, the last one that we saw was common gate amplifier. These three amplifiers I have showed you, and I have told you how to use the small signal model in each of the amplifier to find various parameters like input resistance, output resistance, and the voltage gain. So these topics are very important when you want to find out the gain of amplifier. Don't memorize any expression, just try and use the small signal model and then apply network analysis. Okay, so that is all about the amplifiers. In the next video I'll tell you about the frequency response of such amplifiers.
For 12 months the pricing is 3250, but if you apply the code Ankit ESE it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for Iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that my friend, my personal Telegram channel also you can join, t.me/gateair1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these two channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.